Hello, amazing one. This is what we have. Harvard entrance exam question. Can you solve this? Drop your method in the comments. If you can't, let's do this together. It's just so easy, okay? And don't forget to tell us how it helps you in the comments. We always want to serve you best. Now, to solve this, first, let's do a little check. This is what we are given to get the value of x. Now, let's suppose that our x is 1. If you plug x here, you are going to have 2 to the power of 1 plus 1. You see that when you simplify this, it is not equal to 5. Now let's take x to be equal to 2. We have 2 to the power of our x will now be 2 plus 2. If you simplify this, you see it gives you 6, and 6 is not equal to 5. So what is your observation? You observe that that value of x we are looking for is in between 1 and 2. Now, if x falls between 1 and 2, how do we find that x value? That is what I'm going to teach you. And don't forget to stay through the end because you have a lot to learn. Now, to do this together, what do? We begin this with solution. So let's repeat what we have here. We have 2 to the power of x plus x is equal to 5. Now, what do? We are going to remove this from this side. To do that, you are going to subtract, okay? So we're going to have 2 to the power of x is equal to 5 minus x. Now, what do you think we should do again? We are going to divide both sides by this, okay? So if you do that, we are going to have 2 to the power of x divided by 2 to the power of x is 5 minus x divided by 2 to the power of x. When you divide this goes in itself once. So let's take it to this part we have. So this gives us 1 is equal to 5 minus x divided by 2 to the power of x. Now we can rewrite this to be 5 minus x over 2 to the power of x is equal to 1. Now what do? When you have this, just remember that for every 1 over a to the power of n, it is the same as a to the power of negative n. This is your exponential rule. Now, when we have this, we can rewrite this left side to be 5 minus x, okay, is multiplied by 1 over 2 to the power of x. You have not changed anything because when you make this to be over 1, multiply this, it gives you this. Multiply this by this, it gives you this. So you've not changed anything. So in that case, this is the same as this, and that is equal to 1. Now, obeying what we stated here, we are going to have 5 minus x will be multiplied by, this will now be 2 to the power of negative x is equal to 1. Now, what do? At this point, we just need to remember the use of the Lambert W function, okay? And what does that rule say? It states that for each time you have a, and this a is multiplied by e and is raised to the power of a, you see that this power and this are the same. Just simply introduce your Lambert W function on this, and when you do that, it will be equal to a. So we are going to apply the Lambert W function on this. But for you to apply it, you have to make sure that what you have is of this form. So what do? Let me show you what to do next. So to apply this, we are going to do something to this. So we're going to have multiply. So we're going to multiply both sides. Multiply both sides by 2 to the power of 5. We are doing so because of what we have here, okay? So because we have 5 here, that's why we're multiplying by this base and to the power of 5. So if you do that, we are going to now have 5 minus x into 2 to the power of negative x, multiply it by 2 to the power of 5 is equal to 1 multiplied by 2 to the power of 5. So what do next? Just remember that for every a to the power of m multiplied by this is equal to a to the power of m plus n. So we're going to apply this rule here. To simplify, we have 5 minus x into, then we have 2. The bases are the same, add the power. So we have negative x plus 5 is equal to, if you multiply this, 2 to the power of 5 is 2 multiplied 5 times to give us 32. And 32 times 1 will give us 32. So simplifying more, we have 5 minus x is multiplied by 2. You know that minus x plus 5 is the same as 5 minus x, okay? And that is equal to 32. But remember that our target is on using this. So you see that the power and this are the same, but this 2 is not supposed to be. They were supposed to have this e. So what do? You are going to record that for every e to the power of ln of a, it is equal to a. This is going to be a guide. Now, what do we do with this? For this 2, we can apply this rule here. So to do that, we have 5 minus x multiplied by these 2. Just focus on these 2. Apply this. You have e to the power of ln of 2. Okay? When you do this, it gives you a, and that is 2. So you've not changed anything. And this will be raised to the power of 5 minus x. I hope you are with me there. And that is equal to 32. So what do you do next? Just remember that for every ln of a to the power of x, just your normal logarithm rules, it is equal to the power multiply. So you have x ln of a. So we're going to apply this rule in this. So to simplify, we have 5 minus x is multiplying this power, we multiply the ln, okay? So we have multiplied by e to the power of 5 minus x is multiplied by ln of 2 is equal to 32. Interesting. Now, if you still look at this, you observe that the power is not the same with this, having gotten this e. So what do? You must make sure that the power and the coefficient of this e are the same. So to make it the same, we are going to multiply both sides of this equation by ln of 2. And to do that, we have, so you can take this off now. So we multiply both sides, okay? Multiply both sides by ln of 2, okay? So if you do that, we are going to have 5 minus x multiplied by ln of 2, okay? Multiplied by e to the power of 5 minus x ln of 2 is equal to, multiply this, you have ln of 2 multiplied by 32. Interesting. So you observe now that what we have at the power and what we have at the coefficient of this e are now the same. So at this point, you can now introduce the Lambert W function. And don't forget to give this tutorial a like. Let's know how it helps you in the comments. Share this so that the algorithm catches it and send to more people that need this skill. Thank you very much, and let's continue. So taking the Lambert W function of both sides, we are going to have Lambert W function of 5 minus x ln of 2 to the power e to the power of 5 minus x ln of 2 is equal to, okay, then Lambert W function of what you have here. So you have 32 multiplied by ln of 2. Simple. So what do you do next? Remember, we said for every a multiplied by e to the power of a, when you take the Lambert W function of it, is equal to a. So we're going to apply this here. So having done that, you see that from here, we are going to have, this will give us 5 minus x ln of 2, okay? What you have here and what you have at the power are the same, just like this. So you just pick one of it, that's what we have here, and that will be equal to Lambert W function of 32 multiplied by ln of 2. Interesting. So at this point, we are going to divide both sides by ln of 2 just for us to find x. To do that, we have 5 minus x into ln of 2 is equal to Lambert W function of 32 times ln of 2. So as you said, we divide both sides by ln of 2. Okay, this cancels. So you are having 5 minus x is equal to Lambert W function of 32 multiplied by ln of 2 divided by ln of 2. Now remember that when you have, if you have 5 minus x to be equal to 2, to find x, what it means, 5 minus what gives you 2? It's just the same as doing 5 minus 2 is equal to x. So x will be equal to 5 minus 2. So when you have this, you can just simply have it as x will be equal to, so this will give us x is equal to 5 minus the whole of this function. So we have Lambert W function of 32 multiplied by ln of 2 divided by ln of 2. Now what you do at this point, you can stop it at this point if you are not using calculator. Okay, this gives you the value of x. Now if you are using your Wolfram Alpha calculator, your online calculator, just cue this in. Okay, so you are going to have your x, that is the numerical value. So your x is giving you 1.716. This is approximated value. Okay, so that is the approximated value of x when you use your Wolfram Alpha calculator. And from what we stated earlier, remember we said that the values of x are between 1 and 2. Okay, is in between. It wasn't 1 and it wasn't 2. So you see that what we got here is also a value that is in between 1 and 2. So what we have is correct. And I hope you really learned something. Let's know how much in the comment, and don't forget to like this video. Let's know what you feel about this in the comments. Share this so that the algorithm catches and send to more people. Thank you for always engaging with us. I will see you in our next class. Bye bye.